Okay, so here we go. I'm sure there's going to be 1,000 takes of this, but this is going to be my attempt of teaching you cellular respiration. So let me show you what I've got here. This is my model of glucose here, because the carbon is black like carbon, and it has 6 little dots for 6 protons. So this is C6. This is H12. So each one of these is a hydrogen, and the hydrogen is made up of a proton and an electron. So a hydrogen, remember, is a proton and electron. So if a hydrogen releases electrons, it's just the proton left. So that's our, so we have C6H12, and then here's O6. So that together is glucose. Okay, so cellular respiration is all about using glucose to get ATP. If you forget everything else, remember the overall chemical reaction, which is glucose plus oxygen goes to carbon dioxide plus water. So we're going to need oxygen, but at the beginning, in the first part of cellular respiration called glycolysis, we don't need oxygen. Glycolysis is literally glucose breaking, glycolysis. So we're going to take glucose and we're going to break it into 2 3-carbon molecules called pyruvate. But we haven't gotten there yet. Okay, so remember we have C6H12O6. That's glucose. Glycolysis happens out here in this cytosol. There are 10 steps, so this is an enzyme pathway. There are 10 steps in glycolysis. I'm not going to show you every single step, but I'm going to show you most of the steps. Not that you have to memorize the 10 steps, you don't. But in order to really understand glycolysis, I think you have to kind of see how it works. So what I want you to do is follow along with me. If you have your textbook open to the 10 steps of glycolysis, you can kind of follow along. Okay, so let me show you what the players are. So we have our glucose. We have NAD, which stands for nicotinamide adenine dinucleotide. This is a hydrogen carrier, so it accepts protons and electrons from glucose. So when it accepts a proton and electron, it accepts a hydrogen atom and becomes NADH. And so I'm going to be showing the NADHs by how many little hydrogens I have on here. So they would really be separate NADs for every H I put on it. But I don't have a bunch of cars. So if I have one, that's NADH. There's just one NADH. If I have 2 hydrogens, that's 2 NADH, etc. So when anything accepts a hydrogen, it is said to become reduced. So when you add an electron, remember hydrogen is a proton and an electron, and when a molecule receives an electron, it becomes reduced. The way you remember that is oxidation is loss of electrons, reduction is gain. So oxidation is loss is oil, reduction is gain is Rig. So you remember oil rig. So if it gains an electron, it's become reduced. So when NAD becomes NADH, it gets reduced and it oxidizes whatever it took the hydrogen from. So that's going to be the role of NADH. It's going to take its hydrogen and it's going to transport it to the electron transport chain, which we're going to see how that works in a little bit. So the job of NAD is to take the hydrogen from glucose and take it to the electron transport chain. Eventually, oxygen gas is going to pick up the hydrogen and become water here. Okay, so that's one of our players, is NAD. The other one that I want to show you is ATP. So this is my model for ATP. It has the 3 phosphates, or the little torsos. Actually, the phosphate is going to be just the head of the torso guy. So this has 3 heads, so it's ATP. If I take one of the heads off, it's going to become ADP. So the phosphates are modeled by the heads on little men. So that's ATP. Okay, so let's get started. So So you start out with glucose, and the first enzyme, since glucose is super stable, in order to get it chemically reactive, you have to fork-buttivate it or phosphorylate it. So even though the purpose of cellular respiration is to make ATP, we're going to start out by investing some ATP just to get this molecule reactive. So we're going to take our ATP and we're going to phosphorylate glucose, and that will make this turn into ADP. And we're going to do that to the other side too. So we're going to take another molecule of ATP and we're going to phosphorylate the other side of the glucose. So remember, these are phosphorylated on the carbons. So we're going to use up 2 ATP. So the first 3 steps of glycolysis is making glucose 6-phosphate, then turning that glucose into fructose and making glucose 6-phosphate, fructose 6-phosphate, and then phosphorylating the other side of fructose, which makes fructose 1,6-diphosphate. And I'm going to talk to you later about that third enzyme step, which is really important. So I'll talk about that in the regulation of cellular respiration. So now we have fructose 1,6-diphosphate. The next enzyme is going to split this sucker in half. So we're just going to split the carbons into 2 molecules. We're going to split the oxygens up too, and we're going to split the hydrogens up so that each gets 6. 1, 2, 3, 4, 5, 6, and 6 for this one. Okay. So there we've already done the glycolysis, but we still haven't made any ATP. So here comes the most important step. What we're going to do is we're going to reduce NAD, and in doing so, we're going to gain some energy. So oxidation reduction releases energy, and that energy can be used to do something. In this case, we're going to use that energy to phosphorylate both of these molecules, but not using ATP. So the phosphates that are going to be used are just going to be these free phosphates that come out of just the cytosol. So as NAD comes in and picks up a hydrogen, it gets reduced, this molecule gets oxidized, and that energy is released and used in the phosphorylating of this molecule. So that's one NADH that's formed. The same thing happens with this other one. The hydrogen goes on to reduce NAD, and that energy is used to phosphorylate this molecule. So now we have 2 NADH that are produced. And now we have 2 phosphate groups on each of these 3 carbon molecules. And then what we're going to do with that is we're going to make 4 ATP. So since we have 4 phosphates, we can use that to phosphorylate 4 ADP to make 4 ATP. So even though we used 2 ATP in the first 2 steps, or the first 3 steps of glycolysis, we're going to harvest 4 so that we'll make a net of 2. So we're going to take every ADP, we're going to phosphorylate it to make ATP. Hopefully I can find all my little T's. Okay, we're going to make 1 ATP. Here we're going to make another ATP. Phosphorylate that guy. Make this into ATP. And the same with these 2. Here, we're going to phosphorylate and then make that ATP, and phosphorylate and make that ATP. So now we have 4 ATP, or 2 net ATP. And then what we have left is not glucose anymore. We have 2 molecules of pyruvate. Okay, so that's the end of glycolysis. So the products of glycolysis are 2 NADH, 4 ATP, but remember we used 2, and 2 molecules of pyruvate. So that is glycolysis. I think I'm going to stop this video here. So, but it's not so hard to upload on YouTube, and I'm going to do the citric acid cycle on another video.